Hello everyone, and thank you for attending this presentation today. My name is Daniel Gross, and I am the IT consultant who will provide you with the improvements that I have made to the network design at Canyon Woodcraft. During this presentation, I will cover the topics in detail so you have a good understanding of the positive impact the network changes have made to help support the growth and enhance security for Canyon Woodcraft's network. I will also explain how these changes reflect the current state of the network and how they are helping to support the company as it continues to expand. First, I will discuss how spanning tree protocol and Ether channel configurations were made to the network to prevent looping of network data and increase throughput of data for the company. Next, I will explain what OSPF is and how it was configured to improve the network's resiliency and scalability. Network security concepts, including access control lists, port security, and DHCP snooping will be described and how these concepts benefit the company's network. Network access translation will be covered and how it allows devices to use IP addresses inside of a corporate network to access resources that use public and IP addresses. Next, I will explain how DHCP was configured on each branch office router to automate the assignment of IP addresses and network settings. Finally, I will describe how Canyon Woodcraft's network security relates to a Christian worldview. Canyon Woodcraft's corporate office located in Phoenix, Arizona contains a redundant switching architecture. However, redundant switch connections create a potential risk for network loops and broadcast storms. I resolved this issue by configuring Spanning Tree Protocol and Ether Channel. Spanning Tree Protocol is a protocol that provides benefits of path redundancy while preventing loops in a network and the possibility of broadcast storms. For an Ethernet network to function properly, there can only be one active path between any two devices. Otherwise, without STP configured, multiple active paths among endpoints will cause loops of traffic in the network and endpoints will receive duplicate messages. If a network segment in the spanning tree fails and a redundant path exists, the spanning tree algorithm recalculates the spanning tree topology and activates a standby path. Spanning tree protocol helps to prevent loops in networks and with redundant switch connections to the switches, and they will block unused connections and bring them up as needed. Ether channel connections were configured by taking switch connections and grouping them together, allowing for additional bandwidth, load balancing, and redundancy. With Spanning Tree Protocol, there can only be one active path between any two devices, so Spanning Tree Protocol recognizes parallel links, considers them redundant, and blocks them. A workaround for this limitation of the spanning tree can be done by configuring Ether channel on a switch and aggregating multiple links into one link. This hides the identity of multiple links from spanning trees so it does not recognize them as redundant. This also increases the throughput and speed of network traffic. In the Canyon Networks Woodcraft environment, at the Phoenix office, I implemented Spanning Tree Protocol on 2 core switches to maintain a loop-free environment in a redundant switch network. I also configured an Ethernet channel connection between 2 core switches to maximize throughput and load balance traffic on redundant switch connections to improve convergence and increase throughput in the networks. Canyon Woodcraft has expanded from Phoenix, Arizona into Denver, Colorado, and Austin, Texas. These branch offices in Denver and Austin connect to the corporate office through a private network. To accommodate the intersite communication over private network, the core switches and routers at the corporate and the routers at the 2 new locations are now using a protocol called OSPF, or Open Shortest Path First. OSPF is a dynamic routing protocol that makes it possible for all of the routers across the network to collaborate. With static routing, IP addresses are manually entered into network devices, such as a router or a switch, which directs network traffic to a specific network device. For organizations such as Canyon Woodcraft that have large, complex networks that exist at multiple locations, configuring OSPF allows routers to find alternate network paths to destinations. Loss of network routing recovers much faster than static routing. Therefore, I chose OSPF as a dynamic routing protocol to use for handling network traffic. With OSPF, Routers share their information with linked state databases, and the routers use the data inside those databases. This helps the routers to learn and make decisions about routing data across the entire network. Configuring OSPF improves the network's resiliency and scalability. OSPF configuration is a critical component of inter-site communications at Canyon Woodcraft, and it's essential for the company's operational efficiency, growth, and successful expansion into new markets. After configuring OSPF on a core switch in Phoenix and at the Denver and Austin routers, both Denver and Austin are now sharing the internet connections from Phoenix through the network, and all these routing devices are sharing routing information dynamically. It has been found that employees at the Flagstaff, Denver, and Austin locations have spent too much time using social media. Although guest wireless access is beneficial, allowing devices with uncontrolled access to internal corporate networks is an information security concern. This includes connecting to social media websites. In the Canyon Woodcraft environment, guest laptops are connected to the guest Wi-Fi and to the guest wireless access. The guest laptops were able to access all of the internal Phoenix subnets in the Austin, Denver, and Flagstaff locations. However, we only want guest laptops to access the internet and not be able to access anything internally. Access control lists are used in modern business networks, and they can filter traffic for performance or security reasons. Access control lists work by defining rules that permit or deny access to network resources or data, which helps to protect sensitive information and prevent unauthorized access. By configuring ACLs, both inbound and outbound traffic can be permitted or denied. By managing traffic flow, ACLs also prevent congestion, leading to better network efficiency. I have configured an access control list on the core switches at the corporate Phoenix office that prevent guest wireless access users from accessing anything except the internet. Access control list configuration was also made to the Phoenix, Austin, Denver, and Flagstaff switches to lock down the guest access, preventing users from accessing the website socialgram.com. The users will still have permission to access the rest of the internet. I performed thorough testing and confirmed that guest wireless access was successfully locked down as intended. The Denver branch experienced an IT security event, and unauthorized devices were found to be plugged into wall jacks. The executive team has requested me to implement security features to mitigate the issue. This was done by configuring port security and creating a dummy virtual local area network, or VLAN, then shutting down unused switch ports and configuring DHCP snooping. Port security is a security feature that is configured on network switches and allows control over which devices can connect into a network port. It works by restricting ports to connect to a specific authorized media access control address, known as a MAC address. Since I have not been asked to implement port security using MAC addresses configuration, I decided to implement port security by configuring switches and creating a dummy VLAN and administratively shutting down any unused switch ports. A dummy VLAN was created so that all unused switch ports could be placed into control port security. Therefore, if an unauthorized device gets plugged into a port, it has nowhere to route traffic, since there is no network route associated with it. DHCP snooping was implemented, which prevents unauthorized DHCP servers from sending out IP addresses. It also blocks rogue network attacks and only allows network traffic from the company's trusted DHCP servers. By implementing port security, creating a dummy VLAN, shutting down unused ports, and configuring DHCP snooping, I significantly reduced Canyon Woodcraft's network vulnerability to unauthorized port access, spoofing, and other malicious activities. This ensures that only trusted devices and authorized network communications are allowed on a Canyon Woodcraft's network, maintaining its integrity and reliability with employees and customers. It was reported that a technician working on the Phoenix corporate office router removed the network address translation, or NAT, configuration. Also, the Flagstaff NAT configuration was removed. This caused the internet for all sites to go down. I was asked to restore NAT configuration to ensure all sites are connected to the internet services, including Canyon Woodcraft's customer relationship management, enterprise resource planning, and their productivity apps. NAT allows devices to use private IP addresses inside corporate networks while accessing internet resources that use public IP addresses. A router configured with NAT makes this possible and can enable many internal devices to share a single public IP address. As a result, NAT reduces the need for multiple public IP addresses. Using NAT makes it more difficult for attackers to target specific network devices. Understanding how NAT works and possible configurations is essential knowledge for all IT and cyber professionals. Canyon Woodcraft's infrastructure at the Phoenix corporate office has internal devices that use private IP addresses. Since the Phoenix office needs to talk to devices out on the internet that have public IP addresses, NAT was configured to translate traffic back and forth between private and public networks. I validated the NAT configuration changes on the Phoenix router so all devices with private IP addresses can share one public IP address and communicate with the internet. Canyon Woodcraft leadership requested to limit server infrastructure to the corporate office as much as possible and keep licensing costs down. The servers at each office location have been moved to Phoenix, Arizona. Because of this, DHCP services must reside on the router at Flagstaff, Denver, and Austin. I was asked to configure and verify DHCP on each branch office router. Configuring DHCP on routers for Canyon Woodcraft automates the assignment of IP addresses and network settings, enhancing efficiency and reducing human errors. This eliminates the need to manually enter static IP addresses on devices. This setup supports easy scalability and centralized management using a DHCP server. DHCP is crucial for maintaining network security and simplifying network administration. I was able to configure DHCP on the routers at Canyon Woodcraft's Flagstaff, Denver, and Austin locations. Afterwards, I confirmed that all routers at these sites were able to automatically get assigned with an IP address. Canyon Woodcraft's network design and security relates to a Christian worldview in a few distinct ways. Ethical business practices are enforced at Canyon Woodcraft based on the company's policies and procedures, which all employees are expected to follow. Being kind, trustworthy, and responsible towards others and having faith in the company is of high importance to Canyon Woodcraft. Ethics at Canyon Woodcraft relates to Christian worldview by focusing on human value and dignity. Providing a secure and reliable path for network traffic to follow relates to the Christian worldview, as God will redirect and guide us to the appropriate path that He has planned for us. Serving those in need of help and efficiently managing resources relates to stewardship in a Christian worldview. Being a good steward means being responsible with the equipment and resources that are used at Canyon Woodcraft. Good stewardship also means using time efficiently to complete tasks prior to deadlines as requested by others. By enhancing and securing the network used throughout the company in different locations, we are protecting the company's data, thus building confidence in employees to do their jobs and promote good work ethics. Incorporating the Christian worldview in our company provides employees with a greater sense of respect, morale, faith, and human dignity and value towards others. Thank you for attending my presentation today. I hope all of you now have a good understanding of the network and security changes that I implemented, as well as the current state of the network within Canyon Woodcraft's locations. Please let me know if you have any questions. Thank you.